In this video, I'm going to use contingency tables to help consider conditional probabilities. So a conditional probability is the probability that some event might happen given that something else has already happened. Okay, a contingency table is actually a great way to do these calculations. We'll see that here. So consider a set of 10,000 loan applications. Of these applications, 1,495 were joint and 4,789 already had a mortgage. 950 of these applicants had both of these characteristics. So first we're going to create a contingency table, and then we're going to find the conditional probability that a randomly selected application is joint given that the applicant did not have a previous mortgage. Okay, so contingency table looks like this table that I've created here, and we're going to fill in all of the details, and basically in each box, well, the totals are going to be totals, the sum of the thing, either the row or the column. And in each box, we put the number of applicants who satisfy both conditions. So this box is someone holds a mortgage and it's a joint application and so on. So let's see what we've got. 950 applicants have joint applications and held a mortgage. So this number is 950. I don't know any of these other numbers, but I do know that the total applications that already had a mortgage was 4,789, and the total number of joint applications was 1,495, and I know the total here is 10,000. From this information, we have enough to find everything else. So the individuals has to be the missing 8,505 because we know this row adds up to 10,000. The does not hold a mortgage applicants has to be 10,000 minus 4,789, the missing 5,211. The joint applicants that don't hold a mortgage, well, we know 950 of the 1,495 do hold a mortgage, which means 545 do not. Take the difference. The individuals, so we've got people who hold a mortgage but are individual applicants. Well, that's 4,789 minus the 950. And then does not hold a mortgage is 5,211 minus 545. At this point, it is really easy to calculate conditional probabilities. So we can do this in two ways. There's a formula for this, but we can also do this in a slightly different way. So the conditional probability that a randomly selected applicant is joint, given that the applicant does not have a previous mortgage, well, the given that the applicant does not have a previous mortgage means we are in this row, right? Because we are already restricted ourselves to these 5,211 who does not have a previous mortgage, which means this conditional probability has to be 545 divided by 5,211, or around 10.4546%. Now we can do this in a slightly different way, for which we have a formula, and what we can do is the probability that the applicant does not hold a previous mortgage and is joint, so that's equal to 545 divided by 10,000 divided by the probability that they do not hold a mortgage, 5,211 divided by 10,000. We get the same answer. I tend not to remember the formula. I like contingency tables because I find them a little easier to work with, and it's easier to look at this and say to myself, I am in this row or this column or whatever it is, whatever I'm supposed to assume, I've now restricted my data set, and then it's easy to figure out my probability.